How dare you?
Do you tell like a lot of the same stories every year, or do you just have a lot of stories to tell like?
Well, that happened last night. Like that.
I know, but like when like Penny and Zandy are your students, then like.
I know I'm gonna be out of material.
Yeah.
I'll be like, hey, last night Penny was crying about her boyfriend breaking up with her. No, I can't. Right now they're young enough, and I mean, you know, and Penny loves that you guys know her. She loves it. It's so weird. She goes, I love when I come to school and people are like, hi Penny, and I'm like, hi. And I'm like, yeah. She's like, how do they know me so well? And I'm like, because I tell stories about you. And she was like, funny ones? And I was like, yeah. And she was like, cool. And I figure right around 7th grade, she'll be like, stop talking about me. And I'll be like, oh, it's all done. And people will be like, do you have a funny story today? And I'll be like, I sure do. Can't tell you about it. Gotta respect her privacy now. But not Zandy. Zandy will not get his privacy respected for another 3 years, so we'll have some time. Oh, you're right. My comedy routine is drying up. Okay, gotta figure out what I'm gonna do.
No, they're all funny.
I'm gonna just start like having marital problems or something.
Oh my God.
I'm glad we've recorded all this. Hi, Desi. So, today is 5.2 and 5.3 trig functions, day 3, right? Right. Yesterday was day 2. 11.2. Okay, so we got, I think, some kind of easy stuff today compared to what we've been doing lately. We're going to prove 3 Pythagorean identities, and this is something that you will not be tested on this test, but you will be tested on the next test. So it is important that you know it, but for right now, I'm trying to avoid the Jackson question of, but why does it work?
Oh, this is what I used yesterday on the test.
Mm-hmm. Okay, hey, you have to do this now, so just stop doing the other thing. Okay. So, sine squared plus cosine squared equals 1, and we are going to prove this. So when you're proving a function, you can't work from side to side. You actually have to just work on one side. So it's not like we're solving anything. There's nothing we're solving. We're just trying to make the left side look like the right side when you're doing a proof. So here's how we are going to figure this out. You know what? I think actually I'm going to prove this one using I'm going to use just the Pythagorean theorem for this one. So the other ones I will prove straight with algebra, but this one I'm going to use the Pythagorean theorem. Okay, so imagine you've got a unit circle, right? Let's pretend like we're in the first quadrant and we have like some angle sticking out. Got a curve. Doesn't matter what the angle is. Here's the angle. So I don't need this big line. No, I just don't need that. Okay, so in the unit circle, do you guys understand this is just the first quadrant? I've just drawn like a quarter circle here. So what's the hypotenuse? 1, and it's that way because it's called the unit circle, right? Do you guys remember what the x value is right here? Not what this distance is, but like what function it's equal to? The x is equal to what? No, I didn't tell you what this angle is. On the unit circle, what is x always equal to? What trig function is x always equal to? Cosine. So there's cosine down here. Right, and that's because if you divide by 1, the adjacent over the hypotenuse is still cosine, right? And the sine is that height. So do you guys see where this comes from? Sine squared plus cosine squared equals 1? Because that's the Pythagorean theorem. This is a squared plus b squared equals c squared, right? But why is it just 1 and not 1 squared? 1 squared is 1. Okay, these are called the the Pythagorean Identities. And these are going to go on the back side of your unit circle, just in the top left corner. There's going to be 3 of them. So I'm going to write the Pythagorean Identities. And the first one I'm going to write, there's going to be 3 of them. I'm going to write sine squared theta plus cosine squared theta equals 1. The theta is just the angle that the sine is referring to, and the cosine is the angle that it's referring to. But instead of saying sine theta and then having a squared on the outside, it's, I don't know, a rule to put it after the word sine or after the word cosine or a tangent instead of after the theta. Because otherwise it gets confusing that, like, if your angle was 60 degrees, then the question would be, would you square the 60 degrees or do you square the sine of 60 degrees? So that's how you tell the difference. So that's one of them. All right, the next one we're going to prove was straight algebra. Do you need me to put that back up there? Yep. All right, the second one we're actually going to prove with algebra, and it is tangent squared theta plus 1 equals secant squared theta. There's way too much happiness in that hallway. Gross. All right, what is tangent in x's and y's? Y over x. And if you're like, how did they know that? It's on your unit circle on the bottom. So tangent is y over x, so tangent squared is y squared over x squared. Plus 1. What's secant squared? What did you say? So it's 1 over what? It's x squared. And you can tell that by looking at your unit circle. Do you see where it says secant is 1 over x? And you guys get to use this unit circle on every test. Every single test. You do not have to memorize this. Maybe for Math League, but besides that, you know, if you're not taking the C test in Math League, you do not have to worry about memorizing this. But eventually, you're going to use this stuff so much that you will have at least secant being 1 over x, and probably these 3 trig identities memorized. The rest of the sheet, probably not, but these 3, probably, yes. All right, so now we have to make these sides the same. How do we add these 2 together? How would you add things that where one thing's a fraction, the other thing's not? Make it into a fraction. Okay, now it's into a fraction. That's 1 over 1 now. Yeah, that's right. I just put a line in the middle and freaked you out. Yeah, it's 1 over 1. I'm sorry. No, there's no space there. But, okay, I'll rewrite it.
Good job, Kyle. No, I thought that was like a new symbol.
Wow. All right, I got lazy and confused everyone. That better? Okay, so now, how do you add 2 fractions?
You have to get common denominator.
A common denominator. All right, so now I'm going to change this to y squared plus over x squared plus x squared over x squared, right? Because we need the common denominator to be x squared. And now that I've got a common denominator, I'm going to put them together. And I've got a pen for the person who can explain the end of the proof to me. And I got so many pretty colors. Ooh, look at those colors.
Ooh.
I know. I need somebody who can make the left side look like the right side. No, it can't be you, Crystal. Make the left side look like the right side. Looks like the bottoms already look the same. Think about it. You can use any rule we know. All right, I've seen other people like half raise their hand. Kyle's been strong the whole time. Anybody want to go for it? Come on, be brave. All right, 1, 2. Caitlin, no? You're kind of half. All right, 3. No?
One, sure.
4. You guys are so cute. This is how some of you raise your hands. No, just touching the back of my head. Just love. Just, I'm just chilling. People against the wall are always like, no, it's a big stretch. Stretch right now. Don't call on me. 5?
Yeah.
All right.
Oh. No, just keep it on there.
5. It's you.
Oh.